Hey, good morning, Geometry Honors, or afternoon. Today we are going to talk about the area of sectors, which is the last area to cover this year. So this is actually our last new day of content, which is crazy to think about. So the warm-up, given circle O with arc length AB equals 3 over 2 pi, find the exact area of the shaded region. So if I look at that area of the shaded region is exactly 1/4 of the total area. And the reason I know that is because it's a 90-degree angle as marked, and 90 over 360 is 1/4. So I know if I want to find that area of that shaded, I'm going to do 1/4 times the area of circle O. So now I need to figure out what is the area of circle O. In order to find the area of a circle, that's going to be 2 pi r squared. Okay. So I need to figure out the radius. So I know the arc length, and a little bit of a throwback. We've learned about arc length before. My goodness, my iPad does not like me zooming. So if I wanted to find arc length, I could do the arc length is equal to the arc measure divided by 360, which we've already talked about could be reduced to 1/4, times 2 pi r, since it's part of the circumference. Okay. So now I'm just going to reduce what I can there. So 3/2 pi equals 1/4 times 2 pi r. And then if I multiply that 1/4 in, I have 1/2 pi r. I could divide both sides by pi, and now those cancel. And remember, my whole goal is to find the radius. So if I multiply both sides to get rid of that 1/2, if I multiply by its reciprocal, I get that the radius is equal to 3. Okay. So now I can go back to my area of my circle. 1/4 and then pi. My radius is 3 squared. So 3 squared is 9. And then if I multiply those, I get 9/4 pi, or 9 pi over 4 units squared. And that's that area of that shaded region. So that shaded region is actually an example of what we call a sector. A sector is just a region bound by 2 radii in that arc of the circle. So it's really just part of the area of a circle, just like arc length was a part of their circumference. So we're actually going to use that logic to develop our two formulas. We have two formulas we could use. You're probably going to lean more towards one of them just because it looks more familiar. But since arc length is a part of the circumference, we took that arc measure in both cases and then times your circumference, because you're trying to figure out what part is that. And I know some people just set up a proportion, which is what that second piece is doing. So really you're taking this first equation and dividing by 2 pi r to get the second equation, and either one is fine. So if I apply that same thing here, I'm going to use a different color. I have theta right here, whatever that angle measure happens to be. In our warm-up, it was 90 degrees. If I want to find the area of that sector, which would be that entire shaded region, that piece of that area, I'm going to do theta divided by 360 because we're trying to figure out what portion of the area is that, times the area of a circle, which area of a circle, we really only use one, which is pi r squared. So that's one way to think about it. The other thing you could do is set up that proportion if you prefer that way, totally fine. If I divide both sides by pi r squared, I would have the proportion of the area of the sector is to the total area of the circle, as theta is to 360. So either one, your preference.